Good day, folks. Welcome to my YouTube channel. Thank you for liking all my videos and subscribing and sharing my video. Watch all my videos, guys, please, till the end. Watch all my videos and share with your friends. Guys, for those who are still writing or those who are still going to write physical science, today I decided to do the velocity versus time graph of the vertical projectile of motion. Let's cut the chase. A ball is thrown vertically downwards is very important from the top of the building and bounces few times as it hits the ground. The velocity time graph below describes the motion of the ball from the time it is thrown up to a certain time t. Okay, now it says take down as positive direction and the ground as a reference point. The graph is not drawn into scale, or to scale the effect of air friction is ignored. Guys, let's just draw what is happening there. This is the building, right, and that's the ground. Now this ball is thrown vertically downwards, right? So what's going to happen to that ball? It's going to bounce, right? So when it bounces, looking at the graph that we have here, it's a velocity versus time graph. So surely that ball was thrown by the initial velocity of 10 meters per second. So remember, as the ball goes down, its velocity increases in the positive direction. Remember, they've chose downwards as positive from the graph. So the velocity increases until it reaches the ground. So we have this is the initial velocity, and this is the final velocity just before it hits the ground. Now, if you see here, what is this gap here? This gap, now it took 2 seconds for the ball to reach the ground, but it stayed a little bit longer in the ground for 0.2 seconds. Where does the 0.2 come from? Is the difference between the two. So that means it's the contact time. So there's the contact time, and then there's the ball there, and then the ball goes up and to a velocity of what? With a velocity x. So this velocity x we do not know, and it goes up, and so graphically in the graph it goes up with this velocity and decreases in the negative direction to the maximum point, which is this point. It decreases to the maximum point, and then it continues to go back down and increases its velocity in the positive direction. So here's the increase in velocity in the positive direction after the maximum point. This is the maximum point. So it increases in the positive direction there, and another time we see there's a bounce there. So these two broken lines that are here, they show the bounce. So even the contact time, if you see the gap in between, if these two broken lines were connecting each other like that, there was going to be no contact time. But now there's a space between them. That means there's a contact time between them. So the contact time, it's this minus this. So I guess it's going to be 0.29. So again, there's a contact time. I'll leave the space there for the contact time. And what's happening? It moves up the ball with a velocity. Remember, up is negative. It moves up with a negative velocity that decreases to 0. So where's the so it moves up with this velocity and decreases to 0, which is the maximum point, right? So the time it took, it's t. Guys, I hope that makes sense. So this is the maximum point of this. They're not the same, guys, those maximum point. The reason for that, the velocity when it hits the ground is 27, and the velocity when it leaves the ground it's 25. So they're not going to be the same. That's inelastic collision. So guys, if you're looking at this graph, it shows that motion there, and I tried to show you. Now let's answer the question quickly, guys. Now the question 4.1 says write down the speed with which the ball thrown downwards. So the speed in which the ball was thrown downwards is what? It's 10 meter per second, and it's positive 10 meter per second. Now it says 4.2, all parts of the graph have a same gradient. Give reason for that. The gradient of the velocity versus time, guys, check my previous videos. The gradient of this, it's the gravitational acceleration. So what I'm going to say, the gradient here is gravitational acceleration, which is constant throughout the motion. Right? That's the answer there. So there's 2 marks. Now in 4.3 we're calculating. It says calculate the height from which the ball was thrown. So we are not told this height in which the ball it was thrown, but what do we know about height? This is the displacement that the ball had when it traveled to the ground. For the first time that hits the ground, it traveled that displacement there. So if we can calculate this displacement, that means we calculated we calculated the height of the building, because the ball traveled the distance of the building. So how are we going to do that? I'm going to show you 2 ways. I'm going to do it the easy way and do it the unfamiliar way. I don't want to say the difficult way. So guys, what was the initial velocity here? So we're going to take this segment, guys, this segment, and this segment there is this part of the graph. So this area under the curve here, it tells us the displacement from there to there. So what are we going to do now? What do we have? We have, as I've indicated in the graph, we have the initial velocity, that is 10 meters per second, and the final velocity, that is 29.6 meter per second, and the acceleration, it's 9.8 and it's positive, and it proves our slope of the graph, it's positive slope there. It proves that our acceleration is positive, and we want the displacement, and we do not have time, do we? Okay, we do have the time. So it took 2 seconds from the top of the building to the ground, so we do have time. Forgive me for that. So the time there, it's what? It's 2 seconds. So which formula are we going to use there? In order to get that, I would suggest to use this. Say Vf squared is equal to V initial squared plus 2a. I'm going to tell you why we use that formula. We have the final, we have the initial, we have the acceleration, we want the displacement. So that's the easy one. So the final velocity there, it's 29.6 square equal to 10 square, which is the initial, plus 2 times 9.8. Our acceleration, guys, we chose vertically downward as positive, so 9.8 is positive. We're just double checking. And then, so in our calculator we'll have 29.6 square, and if we take the 10 to that side, it's going to be 100, and 9.6, 2 times 9.8 is 9.6, and then we divide by 19.6 both sides. The 19.6 is positive, so when I quickly punch that in the calculator, it's 29.6 square minus 10 square, which is 100, divided by 19.6. so the answer there, which is the displacement, it's 39.6 meters. What is 39.6 meters? That's the displacement. This is the displacement of the ball from there to there. But what does it mean? What are we calculating? The question, it says it wanted the height. So we say, therefore, the height of the building is 39.6 meters above the ground. Okay. Alternatively, let me show you this. As I've mentioned earlier, So the area under the curve here, we have two shapes. Okay, the area under the curve, guys, always the area under the curve of the velocity versus time graph, it represents the displacement. But now here we have two shapes here. We have the triangle, which is its area is half base times height. Half, what is our base? The base is from there to there, which is, what is that? It's time. So it's going to be time. And what is our height there? Our height there from there to there is the what? Is the velocity. All right, that means that the velocity times time is the what? Is the displacement. So the area under the curve, it tells us the displacement, and we have another shape here to cover the whole area, so you must eat it in pieces. So we have the breadth and we have the length here, right? So what is that? The area here is equal to length times breadth. What is the length is time. What is the breadth is velocity, which is as well, it's the what? It's the change in y, which is the displacement. So this displacement we can get from here to here. It can tell us by, we can get it by the area under the curve there. So that means I'm going to combine those two areas there. So I'll say height of the building. Height of the building is equal to the area of a triangle plus the area of a rectangle there. So their formulas: the triangle, it's half base times perpendicular height plus the area of a triangle, its length times breadth. But I'm going to show you again. The breadth there in the triangle is the time, and the height is the velocity, plus the length there, which is the longest time in the triangle, is the time. The breadth is the velocity. So let me substitute now. In the triangle, what is the breadth? What is a breadth, or the base? The base is what? Is 2. If you're looking there, it's 2 from there to there, it's 2 from there to there, it's 2. So it's going to be what? 2. And the velocity, from 10 to 29.6. So the difference from 10 to 29.6, it's 19.6. But I'll just show it here. So you say 29.6 minus 10, it will give you 19.6, plus the time is still 2 in the rectangle, and the velocity there in the rectangle, it's 10 from there to there, which is our base, our breadth, or the width there, it's 10. So I'll put 10 there. And then when you punch that in the calculator, you get the same answer, 39.6 meters. That's the height above the ground. Guys, quickly, let's go to the next question. 4.3.2, it says calculated the time t. It's 4 marks. The time t, guys, is the whole time for the motion. The whole time for the motion, guys, as we know, from there to there, it took what? 8 seconds. But the only time that we do not know is this time. So where is this? It's starting from the ground. After it's in contact with the ground, it took, for the whole motion and the contact time in the second bounce, it took 8 seconds. And then after that's 8 seconds, the ball ascended and its velocity decreases to 0. So if we can have this time, which is this time, we can add it to 8, and then we get the whole time. So this is 4.3.2. Yeah, 4.3.2. So what do we have here graphically? What do we have here, guys? As I've mentioned here, we have the velocity here, its initial, and we have the final there, which is 0. So those are the two things. And what else do you have? That's all. That's all you have with one time. So the easier for that, you write your diet with data, your information. So the initial velocity there, it's negative 25, and the final velocity is 0. Negative 25 meter per second, and your final velocity at maximum of the last height is 0, and we want time, and we don't have the displacement there, so we avoided the equation. So the best equation for this, guys, is VF VI plus AT, and then the final velocity there is 0, and a negative 25 plus, and the acceleration, remember, it's positive change in t. So if we transpose this to that side, so it's going to be 25 equal to 9.8 change in t, and then we divide by 9.8 both sides, and then our change in t, it's going to be 25 divided by 9.8, 9.8, so it's going to be 2,55 seconds. That's the time. Alternatively, guys, what you can do there, you can use an extra skill. Let's say in this question they said calculate without using the equation of motion. As you can see that I've used the equation of motion there. So without using the equation of motion there, you can use another skill. This is a slope, guys. It has the gradient. The gradient here of a velocity versus time, the gradient of this and the gradient of this, gradient of that. That's what they hinted to you in 4.2. The gradient here is acceleration. So I can use the gradient equation. So we have a point that we have here, it's 8 and what, and 0. So that's our initial. So this is this is the time, and this is the velocity. And then at this point we have a point there that is t and 0. We have a point which is, it's the t final and the v final, and the acceleration there, which is the gradient there, is equal to 9.8, and it's positive. You can see how the slope of that. So alternatively, what we can do there, we can use the gradient. We can say acceleration is a gradient, change in v, change in y over change in time. So our change in y is going to be change in v, and our change in x is going to be change in t, and then we're going to have v final minus v excuse me, guys, and then a t final minus t initial. So we still have those points. So the gradient here, I'm going to substitute 9.8, and the v final there is 0 minus the v initial. There's no way, guys, these points are wrong. Let's fix the points. These points are wrong here. So here we have 25, and these points are wrong, guys. I hope you noticed that. And so this is t initial. So t initial, it's going to be 8 and negative 25. That's the point there. 8 and negative 25. So the v final minus the v initial, so it's going to be 0 minus 25. Where am I? It's going to be 0 minus 25, and then the t final there, it's t minus 8. So it's t minus 8, t minus 8. So let's just write here. So it's going to be 9.8 equal to 0. Okay, 0 plus 25, so it's going to be just 25. 25 divided by t minus 8, and then when you cross multiply there, you have t is equal to 25 divided by 9.8 times not times plus 8. T is equal to it's going to be the time is, this is going to be 2,55 plus 8, which is t is going to be 10,55 seconds. So the whole time is 10,55 seconds. So here I did not finish this, so we have this time, which is 2,55 from here to here. So we're gonna add with 8, so which is t. So t is equal to 8 plus 2,55. That makes what? 10,55 seconds. That's the time. Let's look at 4.4. 4.4, it says write down. 4.4.1, it says write down the time the ball is in contact with the ground for the first bounce. Let's look at the first bounce. So the ball is in contact with the ground for the first bounce. So the time is 2.2. It's 2 to 2.2. So to calculate that difference there, so you say change in t is equal to 2.2 minus 2, which is 0.2 seconds. That's how you calculate the contact time. You take the biggest time, you minus the small time, and then you get the difference between them. Okay. Now it says 4.4.2, calculate, write down the time which the ball reaches its maximum height for the first bounce. Where was the first bounce? This is the first bounce, right? And it reached the maximum height there. This is the maximum after it has bounced from here, it contact with the ground and bounce again. So we want this time here. So this is the bounce and this is this part, and then it decreases its velocity to 0, which is there. So it reached the maximum height at 4 point, let's write it there, at 4.955 seconds. Now the value of x, let's look at the value of x in the graph. The value of x in the graph, guys, if you can see this part of the graph, it's when it leaves the ground. It leaves the ground from the first bounce with that velocity and reach the ground with the velocity of what? Of 27. So these two values are equal. These two values, they should be equal. But this one, it's negative because it's going in the negative direction, and this one is positive because it's going in the positive direction. So the answer there, it's the same value, but it's negative 27. So it's negative 27 meters per second. That's the acceleration, that's the velocity x